All right, so in this video, we are designing the lower control arm for the Ultra4, and I'm starting by figuring out how I'm going to mount the lower control arm to the frame. I found some really big bushings online from trophy truck parts suppliers, but none of them were quite big enough. So I think I'm going to go with custom sized polyurethane bushings, and then I can retain the same size 1-inch hardware on the mounts that attach the lower control arms to the frame. So going through the process of designing a custom polyurethane bushing here, this is way bigger than anything that I could find online. And I think these are going to be really, really strong, which is nice. So this is the sleeve that the bolts are going to attach to. So I haven't done this in the past, but this is proper suspension design where you have metal on metal between the sleeve and the bolt, and then you have polyurethane between the sleeve and the lower control arm billet. And the reason for that is that anytime you hit a big bump, that polyurethane is going to absorb some of that impact and allow the lower control arm to flex with respect to the frame, which is super crucial. If everything's hard mounted, then all that force goes into the welds. And so you actually want a little bit of compliance in the longitudinal direction of the suspension assembly, because the suspension allows compliance in the vertical direction. But if you hit a big rock, the only way for that force to be absorbed is for the lower control arm to move back a little bit by way of compressing the polyurethane bushing. So now I'm working on getting the approximate shape for the profile of the lower control arm, and I'm referencing that suspension sketch that I did earlier to get the cycling dialed in 2D before I start designing it in 3D. And what I'm realizing now is that the cuts that I'm going to make need to be on a strange plane, and if I can get those little angles there to be perpendicular to the angle of the cuts, it's going to make my fillets a lot smoother, and it's going to make the part a lot easier to machine. So that's what I'm working on here. So grabbing that spherical bearing, again, this is the biggest bearing that I could find on McMaster. It's a 3.5-inch OD and a 1.5-inch ID, and it allows for some really serious bolts. So I'm making these cuts here. This is where the lower control arm is going to interface with the tall knuckle. And so I'm grabbing the hardware that I used on the top part of the tall knuckle, which is a C-clip with a little groove in there, and then flanged boss to capture it on the other side, and making sure that all those dimensions are identical between those two parts, making sure that the chamfer is the right size so that it can allow the misalignment spacers to cycle without interfering, and saving this part as lower control arm. That's super exciting because that means the front suspension is halfway done. So these cuts are to make room for the center diff, and this is where the bushings are going to interface. So what I like to do in these assemblies is make all of the parts fixed in space at a neutral ride height, and then make sure all my mates are correct. That way nothing is moving around in space, and in case I need to do any reference geometry, everything's going to work out. So what I ended up doing with this part is making it a larger assembly that includes all the hardware, but that's going to come later. I'm fixing some of these angles so that the cuts are going to be correct. So you can see how I have those two kickdowns that are at different angles, which would make the part really challenging to machine on the vertical operation. But I think if I get those angles to be parallel to each other, it's going to make the whole thing a lot easier to cut. So these circles represent a mock-up of where the shocks are going to go. So the biggest shocks that I could find from King were 4.5-inch bypass shocks and coilovers. They actually sometimes call them coil carriers. At least that's what the off-road guys call them, but King doesn't necessarily call them that. They also don't show coil carriers on their website. A coil carrier is just a coil over without any oil in it. So it's assuming that you're going to use that in addition to a bypass shock without a coil on it. So the coil carrier bears the weight, and the bypass shock does all the damping. So I'm making sure that I have enough room for all of those shocks. This is an old model that I had made years ago on a different buggy design, and it just so happened to be the right outside diameter, and I'd already gone through the work of making the top and bottom mounts and putting the spherical bearings in there. So I'm just going to save this assembly into my Ultra4 folder, and then I can modify these parts. Alternatively, you could do a pack and go on this part, which is what I ended up doing for the coil carrier, but I wasn't sure how the McMaster parts would act if I did a pack and go with a suffix on the end of it. It ended up being okay. So these shocks need to be 20-inch stroke. So the housing and the shaft need to be 20 inches each, and then I'm going to use about 16 inches of the stroke. So saving all of these parts so that I can edit them. What I like to do on shock assemblies is make different configurations of them. So I've got an upper configuration, a lower configuration, and then the default, so that I can load the assemblies in and then swap the configurations to make them line up with each other, so that you have two discrete assemblies representing the same shock, but they're able to cycle independently of each other. So now we're looking at the coil carrier, and this was a really cool part because I used a spiral cut to represent the threads. I didn't want to rebuild this because I remember this part of it being kind of tricky, getting those spiral bosses to line up to represent the threads. And it just looks really cool as it is, and it's the right size. So just decided to use that as it is. So I need to modify some of the dimensions here. The previous design that I used these on had an unrealistic amount of wheel travel because I didn't really know that much about CV angle constraints. And I was also referencing like monster truck nitro shocks, which are way bigger than anything you would use in like a race application. They're just the biggest shocks that King makes. So a lot of the time in this assembly is spent getting all of the parts to be mated to each other properly and then checking all of my dimensions. So what I like to do is on the shocks, I have those spherical bearings that are fixed in space in the upper assembly, and then I mate the shocks to them. So that's what you're seeing here, is all of these little spherical bearings are going to be fixed in space, and then I will end up building the frame around those mounts. I'll build the front bulkhead around those location points. So just modifying the assembly configuration here on the shocks, making sure that I have everything set up the way that I need it to be to get it to mate properly and cycle properly. And I ended up organizing all of these front suspension parts into a folder because it makes it a lot easier to hide everything else in the assembly. So in SolidWorks, that function is called isolate. So you can be in a really big assembly, maybe it's kind of slow. You select the parts that you're working on, and then you right click and go to isolate, and then you only see those and everything else is hidden. It makes the program run a lot faster and helps you to not get too lost in the sauce in the upper assembly. So those spherical bearings, luckily for me, are going to accept a 1-inch bolt, so I can use the exact same hardware that I use on the tall knuckle, which is nice. And for those, I'm using grade 8 stainless steel threaded. They're almost like threaded studs, but they're hex bolts, but they're partially threaded. So now this is the challenging part, which is I have to figure out what kind of cuts I need to make in the lower control arm to mount the shocks. And so what I want is for those shocks to be mounted on the center line and to have these little cutouts, and make sure that there's enough room for the bolts to get through it, for the clearance of the shocks during cycling. And so I'm referencing this design from Dobry Designs. Really like that guy. He has some really great videos explaining Ultra4 front suspension design, and I learned a lot from him. So he has some really cool chromoly assemblies for both rear trailing links and lower control arms for Ultra4. And I think he designs cars for Jordan Pellegrino. So he definitely knows what he's talking about. And so I decided for this one to go with billet 7075. And then what I want to do is wrap this whole part in chromoly plating on the thinner parts. So the reason for that is if I was to fabricate something like this out of sheet metal, it's just way beyond my fabrication skills, and getting everything to be super precise when you're welding chromoly sheet is really hard because you have to design a bunch of fixtures around it as well. Whereas a billet part like this, although it might not be as strong as chromoly, it's going to be a lot lighter, and you're going to be able to put a lot more precise features in there, especially for these two shock mounts. So some of these holes that you're seeing here are assembly clearances so that I can fit bolts in there and make sure that the shocks can go in, those heat treated stainless inserts can go in, and the 1-inch grade 8 bolts can go in as well. So these heat treated stainless inserts, this is not an off the shelf parts. I emailed the guys at 74 Weld to see where they get theirs, and they said they build them in-house because it's just a simple lathe operation on bar stock to make those, and then you send them out for heat treating. So that makes perfect sense. Plus everything in this design is custom so far, except for the bolts, basically. So I see no issue with that. Right now, I'm sort of chasing my tail on this assembly because I can't figure out why that part is mated the way that it is, and it's still rotating. Whenever you're in a SolidWorks assembly, if you see a little minus sign in a parentheses at the front of a part, that means that that part is unconstrained in at least one dimension. And for stuff like this, every part in this assembly should be fixed because nothing is moving. Whereas in the upper assembly, you want some stuff to be fixed and some stuff to be moving for cycling. So just trying to figure that out. I ended up finding that it was a circular mate that was not locked in rotation. So figured that out later. So yeah, now I'm adding these spherical bearings to this assembly, and I like to have all the hardware in each subassembly so that it's a lot easier to visualize which parts are fixed and which parts are moving. It also is easier for SolidWorks to figure out which parts can cycle without breaking a bunch of mates. So that's what I'm working on here, figuring out how to mount the shocks in there and realizing that I need to make some clearance cuts. So what I ended up doing was increasing the height of the shock mount. So that would be the distance from the bottom of the coil to the center of the spherical bearing. I had originally had it set to 2 inches, but there was too much interference, so I ended up doubling that. Otherwise, I would need some crazy cuts in here that would compromise the structure of that lower control arm. So now these parts are a lot taller and there's plenty of room for clearance. So now I just need to simplify some cuts here, and then the whole thing will be able to cycle really easily. So this mate that I'm editing is the lower control arm suspension angle. So my goal was 30 degrees of suspension travel in the negative direction, but I'm constrained by the misalignment spacers to 25 degrees, which is still plenty. I'll end up with almost 3 feet of travel on the front, which is, that's as much as trophy trucks have in the rear with a solid axle and 6-foot long trailing arms. So I figured 25 degrees is plenty, and then ended up with these really neat cuts right on the top of the part, super easy to machine, and there's plenty of room for clearance. So the next thing I'm doing is adding fillets for all these ball and mill operations. And so rather than making straight pocket cuts that are super easy to machine, I'm just assuming this is going to be a big complex part. Ball and mill operations are okay, and as long as I radius the inside corners, it will be totally machinable. So I'm fighting the urge to put in all my lightweighting cuts on this lower control arm because it just makes the part look really cool. It makes it look done. But I also realize that the sooner I do that, the more complicated the part's going to get and the more constraints I'm going to have in the future, because in the near future, I'm going to need to make some more clearance cuts for steering and for the tall knuckle. The dimensions that I'm adjusting now are the shock mount locations because they were interfering with the tall knuckle. So I need to move them back about 6 inches, and then there's plenty of room there. So this made the lower control arm really, really wide, which is okay because it just reduces the torque loads on everything. It reduces the moment arms on the mounts, which reduces the force. So I will have to increase my wheelbase because of this, because otherwise when these lower control arms cycle, they're going to run into the driver's feet. But that's okay because this is a gigantic buggy, and another 6 inches of wheelbase is not going to hurt anything. So whenever I do interference analysis, what I like to do is make one of the parts transparent and then figure out where it's touching. So that was really easy to visualize here. I just need to make a nice little cut here on the tall knuckle rather than cut into the lower control arm, because that flange that I'm cutting into was not really structural. It just happened to be there, so it was easy to remove. And yeah, so now final steps are adding some fillets and radiuses to the tall knuckle because this part is largely done. And seeing how that looks in the upper assembly. And this part is done. So then we'll move on to the upper control arm next.